Hi everyone, welcome back to our channel once again. So in this video, we are going to study about the RC circuit where the capacitor has enough time to charge completely and discharge completely. To understand that, let's consider a RC circuit where resistance value is 1K and the capacitor is 1 microfarad. So the time constant for this circuit, we can write it down tau equals R into C, which comes to 1 millisecond, right? Now, let's give a step input of 0 volt to 9 volt in this way with a time period of 20 millisecond and pulse width of 10 milliseconds and tau what we have calculated is 1 millisecond, right? So from this what we can say is tau is much less than time period and tau is also much lesser than the pulse width. It means the capacitor has enough time to charge completely and discharge completely as well. So to understand this, to draw the output waveform for this, we have to draw the output waveform for the given circuit. Output waveform across the capacitor. Let's say this is the output. To do that, we'll try to apply two approaches. One is the analytical approach without writing the equation across the voltage equation across the capacitor. So first approach, let's see without writing the mathematical equation. So what we have is 9 volt maximum, 0 volt and 10 milliseconds. Here we have 20 milliseconds, so on. This is the one time period, right? So if tau is 1 millisecond, it means it will charge almost 63.2% of the total voltage in 1 milliseconds, right? So it takes around 4 to 5 time constant to completely charge and settle down. Thereby, the output waveform will start at t equals 0 because at t equals 0 the capacitor will behave as a short circuit, right? So the voltage across the capacitor right after the closing the switch, if we consider a switch here, it is 0 volt. So it will start from 0 and reach till 63.2% of the 9 volt in 1 millisecond. This is 10 milliseconds. After that, it will take a couple of more tau to reach and settle down completely very close to 9 volt. It will stay at 9 volt until the input voltage is 9 volt, okay? So capacitor is now fully charged and settled down to a voltage of 9 volts. Right after 10 millisecond, the input step is dropping down to 0 volt. Thereby, this you can think as a short circuit. By that time, the capacitor is fully charged. Now it's time to discharge the capacitor through this resistor of resistance 1K. The capacitor will start discharging and this will behave like a battery kind of, okay? So it's 9 volt now, very close to 9 volt. Again, it requires one time constant to discharge, another 3 to 4 time constant to discharge completely to 0 volt. Okay. Actually, it comes very close to 840 microvolts. So I'm assuming that we'll see through the mathematical equation. And then stays at 0 volt till t equals 20 milliseconds. Again, the process continues. Okay. It stays here at t equals 30. Discharges and again stays. So this time constant is basically here it will be almost completely settled down to 0 volt 4 to 5 tau. Okay, so 4 to 5 milliseconds. Okay, so at 14 milliseconds will be somewhere near here. Again here exactly 9 volt would be somewhere near 4 tau, 4 to 5 milliseconds. Okay, so this is the rough sketch of RC circuits where time constant is much lesser than the time period of this circuit. Now to understand this mathematically, what we can do is at t equals 0, VC is 0, right? Voltage across capacitor is 0 because it will behave as a short circuit. When t is greater than 0, it means when t is from 0 milliseconds till 10 milliseconds, okay? The capacitor will be charging, right? Will be charging 9 volts. So it will charge maximum up to 9 volt. Thereby the equation will be somewhere Vc of t equals V naught into 1 minus e power t by tau, and tau is 1 milliseconds, right? So if we put the values in this, V naught is 9 into 1 minus e power minus 1000 t volts. Okay, now this is for time t equals 0 to 10 milliseconds. So right after 10 milliseconds the voltage, input voltage, is dropping down to 0. It means now the capacitor will start discharging and this will be again sorted. Okay, so we can write down the discharging equation of the capacitor, which is Vc of t equals 9 into e power minus t minus 1000 into t, but right now discharging starts from t equals 10 milliseconds, thereby we'll shift it by 10 milliseconds. Okay, for again this is for t equals 10 milliseconds to 20 milliseconds. Okay, so this is all about mathematical equations for these two cases, and the graph will keep repeating. So if you want to find out the exact value of at t equals 10 milliseconds while it starts discharging, for that you can put in this equation t equals 10 milliseconds. That will give you somewhere near very close to 9 volt, which can be put, if you round it off, it will come to 9 volt. So this is all about the RC circuit, where time period is much more the time constant